Welcome to this industrial workshop, transforming scrap metal into precision parts today. Workers sort through piles of used aluminum components ready for the recycle process. They load these broken pieces carefully into the crucible furnace for melting down. Meanwhile, other technicians prepare the heavy metal molds for the upcoming casting. Cleaning the mold cavity ensures the final product gets a smooth surface finish. Molten metal reaches extremely high temperatures before it can be poured safely out. Once liquid enough, the molten aluminum is scooped out of the heated furnace. The operator carries the ladle filled with glowing hot liquid metal over there. Carefully pouring the alloy fills the cavity to form the basic shape of part. Steam rises sharply as the hot metal meets the cooler walls of casting mold. Workers use simple tools to compact the metal while it is cooling down fast. This step helps eliminate air pockets and strengthens the structural integrity greatly. After a short waiting period, they prepare to open the mold and reveal casting. Using hammers and pry bars, the heavy metal clamps are loosened. Carefully, slowly, the top half of the mold is lifted away to expose the solidified aluminum block. The new part falls free onto the platform below with a satisfying heavy thud. Now the rough casting is separated completely from the gating system nearby. Excess material is knocked off manually before moving to the next stage here. Quality control begins early by weighing each batch of manufactured components carefully. Stacks of identical parts are placed on a digital scale for precise measurement now. Consistency in weight indicates consistent quality across every single production run. Next, the raw castings move to the cutting area for further mechanical refinement. A large abrasive chop saw slices off the unwanted runner channels efficiently there. Sparks fly brightly as the blade cuts through the hardened aluminum alloy quickly. Each part is now trimmed clean and ready for the machining process ahead soon. Operators stack the cleaned pieces neatly to prepare them for the lathe station. One worker places a single unit securely into the 3-jaw chuck clamp tight. The lathe spins rapidly while the cutting tool shapes the outer diameter precisely. Metal shavings curl away like ribbons as the surface becomes perfectly smooth there. Multiple passes ensure the dimensions meet the strict engineering specifications required today. Once turning is complete, the part is removed and inspected closely by human hand. The finished turned pieces show a bright metallic shine compared to their raw state. They are stacked vertically to maximize space before entering the milling zone next. Here, a specialized fixture holds 4 parts at once for simultaneous processing now. The operator secures each casting into the custom-designed work, holding jig firmly. This setup allows the machine to drill multiple holes in one single operation cycle. The CNC control panel is activated to start the automated milling sequence immediately now. Spindles descend rapidly to drill pilot holes into the top flat surfaces cleanly. Coolant floods the area to prevent overheating during the intensive drilling phase time. Shavings pile up around the fixture as the drills penetrate deep into the metal. Precision is key here, since these holes will align with other mechanical components later. Once the drilling cycle finishes, the machine retracts its tools safely upwards fast. Workers remove the newly machined parts from the fixture for final checks now. Clean air blasts away the remaining debris left from the cutting tools instantly. The parts look incredibly clean and professional after this extensive machining session here. Moving along the line, we see another set of similar components waiting processing now. Attention shifts to a different type of component involving complex gear mechanisms soon. Shafts with small splines are prepared for the gear shaping machine located below. An operator inserts a steel shaft into the vertical holder of the shaper tightly. Heavy-duty cutting oil is pumped over the workpiece for necessary lubrication always. The cutter engages with the shaft to begin forming the gear teeth profile precisely. Intense friction creates heat, requiring constant flow of orange-colored coolant fluid. The machine reciprocates up and down to slice away material layer by layer, slowly. This traditional method ensures very accurate tooth spacing for transmission use cases. Steam and smoke rise slightly as the hot metal meets the cooling fluid stream. After several minutes of cutting, the gear shape is fully defined, clearly visible. The operator stops the machine and removes the freshly cut gear shaft gently. He inspects the teeth visually to ensure no defects occurred during production process. The sharp edges are smoothed out slightly by the natural cutting action itself now. These small gears are critical components for the larger mechanical assemblies built. Back at the main casting line, more parts are being loaded into fixtures steadily. Another batch enters the milling center for additional hole drilling operations there. The machine head moves automatically from one part to the next in sequence. Precision drills create threaded holes that will accept bolts for final assembly later. Metal chips scatter everywhere, covering the machine bed in thick silver dust layer. Workers wear protective gear to avoid inhaling fine metallic particulate matter here. Every movement of the machine is programmed for maximum efficiency and speed daily. The sound of the spindle whining fills the workshop air constantly all day. Finished parts are removed and placed into bins for the next inspection phase. Consistent volume production keeps this factory running at full capacity every day. Let us look closer at the detailed texture of the freshly machined surfaces now. The tool marks indicate a high level of skill from the machine operators working. Even complex internal geometries are accessible using these advanced drilling heads effectively. Workers clear away the massive piles of aluminum shavings regularly with care. Recycling this scrap back into the furnace completes the circular manufacturing loop fully. Efficiency and material usage is vital for keeping costs low in mass production. The final inspection ensures that only perfect parts leave this facility floor today. Any rejected items are sent back to be remelted and recast entirely again soon. We return now to the gear shaping section for a final detailed look closely. The cutting process continues with relentless precision on another new steel shaft. Oil splashes dramatically, highlighting the intensity of the mechanical contact forces involved. The cutter wheel rotates slowly, while the workpiece moves linearly beneath it. This interaction generates the involute curve necessary for proper gear meshing functions. Time-lapse effects show how quickly a rough blank transforms into a functional gear. Workers monitor gauges to ensure pressure and temperature remain within safe limits always. Safety protocols are strictly followed, given the heavy machinery involved in this shop. The rhythmic motion of the shaper provides a hypnotic industrial atmosphere constantly. Coolant levels are checked frequently to maintain optimal cutting performance conditions there. Once done, the part is wiped down to reveal its true metallic luster again. The operator compares the result against a standard master sample for verification purposes. Satisfied with the outcome, he signals for the next piece to be loaded up. Production flow remains uninterrupted as skilled hands manage each workstation efficiently now. This segment concludes our tour of the initial machining phases completed today. Stay tuned for the next segment where we see assembly and finishing steps next. The combination of old-world techniques and modern tools creates truly unique results. From scrap heap to precision engine component is quite an incredible journey here. It highlights the value added through human labor and mechanical expertise combined together. Each bolt hole and gear tooth represents hours of concentrated effort put forward. We hope you enjoyed seeing how metal is transformed right before your own eyes. Please subscribe for more content showcasing industrial craftsmanship found worldwide daily. Thank you for watching this detailed breakdown of the manufacturing process shown. Until next time, keep exploring the hidden world of engineered solutions available now. This concludes the first part of our comprehensive guide on metalworking today. Look at this massive bin of raw gear shafts, ready for the next stage of manufacturing. These steel shafts are the heart of the hydraulic pump, waiting for precision finishing. A skilled operator selects a shaft and mounts it onto the grinding machine. The grinding process begins, removing microscopic layers to ensure perfect cylindrical accuracy. Watch the sparks fly as the abrasive wheel shapes the metal with intense heat and precision. Coolant is sprayed continuously to prevent overheating and maintain the metal's structural integrity. This grinding step is crucial for reducing friction and ensuring the gears mesh smoothly later on. The operator carefully monitors the process, ensuring every dimension meets strict tolerances. Once finished, the shiny, smooth shaft is removed and inspected for quality. You can see the fine finish on the gear teeth and the shaft journal, ready for assembly. These completed shafts are piled up, waiting to be paired with the pump housing. Here we see the aluminum pump bodies and the figure-8 rotors that create the pumping action. The machinist prepares the lathe, setting up a specialized fixture to hold the pump body. He secures the fixture onto the lathe spindle, ensuring it is perfectly centered. The large hand wheel is turned to bring the cutting tool into position for machining. Two workers coordinate to align the heavy fixture and lock it into place. The lathe spins up and the cutting tool begins to face the surface of the fixture. Metal shavings fly off as the surface is smoothed out to create a perfect mounting face. The operator checks the alignment and makes fine adjustments to the tool post. All the components are laid out: the pump body, rotors, shafts, and side plates. Now the main pump body is clamped into the lathe chuck for machining. The worker tightens the chuck jaws securely around the aluminum block. He activates the lathe, and the heavy aluminum block begins to rotate rapidly. The cutting tool engages, shaving off layers of aluminum to true up the outer diameter. Long ribbons of metal swarf are produced as the tool cuts through the material. The operator carefully controls the feed rate to ensure a smooth surface finish. He moves the tool across the face of the pump body to create a flat sealing surface. The precision of this cut is vital to prevent hydraulic fluid from leaking later. The tool continues to skim the surface, removing any imperfections from the casting. You can see the shiny machined surface emerging as the tool passes over it. The operator stops the lathe to inspect the progress and clear away chips. He uses a brush to clean the chuck and the workpiece before the next cut. The pump body is rotated in the chuck to machine another side or feature. He tightens the chuck again, ensuring the block is held firmly for the next operation. After machining, the worker uses a micrometer to measure the dimensions. He checks the diameter and thickness to ensure it matches the engineering drawings. Precision is key here. Even a fraction of a millimeter can affect the pump's performance. Satisfied with the measurements, he sets the finished pump body aside. Now we move to assembly, starting with the side plates that hold the bearings. The worker applies a generous amount of grease to the bearing seats. This lubrication helps with initial startup and protects the bearings. He places a blue sealed bearing into the greased recess of the side plate. Using a specialized drift and a hammer, he gently taps the bearing into place. He ensures the bearing sits flush and is perfectly seated in the housing. This process is repeated for all 4 side plates on the assembly tray. He checks the seating of each bearing, making sure there is no play. The hammer strikes are rhythmic and controlled to avoid damaging the bearing races. Once the bearings are in, he prepares to install the retaining rings. He uses a small tool to press the circlip into the groove inside the bearing bore. This circlip prevents the bearing from moving axially during operation. He carefully maneuvers the ring into the groove, ensuring it snaps into place. A pair of pliers is used to expand the ring and seat it securely. He checks each plate to confirm the retaining ring is properly installed. The assembly of the side plates is now complete and ready for the next step. Next, he takes the wear plates with the figure 8 channels. He places a large black O-ring seal into the groove on the side plate. This O-ring will seal the high-pressure oil inside the pump housing. He ensures the O-ring is seated evenly without any twists or kinks. He stacks the finished side plates, ready to be assembled with the main body. The worker picks up the figure 8 rotors and the gear shafts. He slides the rotors onto the shafts, matching the keyways or profiles. The rotors must slide on smoothly to ensure proper alignment. He inspects the fit, making sure there is no binding between the rotor and shaft. All the internal components are now prepared for the final assembly. He takes the main pump body and inserts the first gear shaft assembly. The shaft slides into the bearing bore in the pump body. He then inserts the second shaft, meshing the two figure 8 rotors together. The rotors interlock perfectly, ready to trap and move hydraulic fluid. He checks the rotation by hand to ensure the gears turn freely. Now he places the side plate with the O-ring onto the pump body. He aligns the bolt holes and ensures the plate sits flat against the body. The cover plate is placed on top, sandwiching the rotors inside. He inserts the long through bolts to hold the entire assembly together. He starts threading the bolts by hand to avoid cross-threading. Once all bolts are started, he uses a wrench to tighten them down. He tightens the bolts in a cross pattern to ensure even pressure on the plates. The pump body is now fully assembled and looks like a solid unit. He flips the pump over to install the shaft seal on the other side. He places the seal housing and the seal itself onto the shaft. He uses a tool to press the seal into place, protecting the internals from leaks. He tightens the lock nut on the shaft to secure the seal and bearing. The pump is now mechanically complete and ready for testing. He takes the finished pump to the testing station. The pump is mounted onto the chuck of a lathe, which will act as the motor. He tightens the pump onto the lathe chuck securely. He prepares a bowl of hydraulic oil for the test. He pours oil into the inlet port of the pump to prime it. Priming is essential to prevent dry running and damage to the gears. He starts the lathe, spinning the pump shaft at a moderate speed. The pump begins to draw oil in and push it out the outlet port. He monitors the flow to ensure the pump is building pressure correctly. The smooth rotation indicates that the internal clearances are correct. He continues to run the pump, checking for any leaks around the seals. He adds more oil to keep the pump lubricated during the test run. The oil flows steadily, confirming the pump is functioning as designed. He stops the lathe and removes the pump from the chuck. The pump has passed the initial functional test. He cleans the exterior of the pump to prepare it for marking. The finished pump is placed on the bed of a laser engraving machine. He positions the pump under the laser head. The laser activates, burning the model number onto the aluminum casing. You can see the text model A25 per 6.0 appearing on the side. Final step is branding, where a fiber laser etches the logo onto the aluminum casing. You can clearly see the Hamer brand name being permanently burned into the metal surface, right underneath. The specific model number, A25 per 6.0, is engraved for easy identification. They also add the date code 1416, ensuring every single pump is fully traceable. Notice the black end plate has embossed text like FEV-D7, adding to the rugged industrial look. Laser marking is superior to paint or stickers, because it won't fade or peel off over time. The operator lifts the finished unit, giving us a final look at the crisp engraving quality. With the labeling complete, this hydraulic gear pump is ready to be boxed and shipped.